Dear scholar, today we will discuss t-test and ANOVA. First of all, what is a t-test? The t-test has three types. First is independent sample t-test, paired sample t-test, one sample t-test, and we also see the test of significance. There is other form of t-test, that's a one-way ANOVA, in which we apply post hoc comparison, contrast, and first of all, what is a t-test? The t-test is a procedure used for comparing sample mean to see if there is a sufficient evidence to infer that the mean of corresponding population distribution also differ. The important things are in the t-test are it's for two. T-tests always compare two different means, sometimes two different group. T-test also has some variable of interest. So mostly we use the SPSS for applying the t-test. SPSS save our time and energy, and if we do not have sufficient of knowledge of the statistic, no problem. We can find all the results using the SPSS. So SPS provide three different type of t-test: independent sample t-test, paired sample t-test, one sample t-test. SPS produce two tail significance value by default. One tail test, two tail test. In the upcoming slides, we will discuss about these type of the test and significance tail t-test. First of all, we will compare the difference between independent sample t-test, paired sample t-test. Independent sample t-test is the two in which we have the two sample share some variable of interest in common, but there is no overlap between membership of the two groups. It means we take the two independent group in the independent t-test. For example, if we compare the running speed of horses and zebra would be an independent design as there is no sensible way to pair off each horse with each zebra. So it means that we compare the two groups, not individual population, individual one to one person. On the other hand, paired sample t-test usually based on the group of individuals who compare both independent of the variable of interest. This test is also called dependent test, a repeated test. Uh, Example of such kind of test is like to compare the running speed of horses for a week of eating over a field with the same horse over a different type of field. Then we compare the population of these two types, and then we find the result. So here are independent t-test. For example, in independent t-test, we compare the males and female. We take the example from our university. If we compare the result of male of MPhil student and female of the MPhil student, then we apply the independent t-test. On the other hand, pair sample t-test, if we apply in the MPhil student, at the start of class, we will take the quiz of all the students about the statistical courses, and then we teach in the whole semester. And at the end of semester, we will also take the quiz and we will compare the result of the first quiz and the second quiz, and then we find whether there is a significant difference in the student result or not. The third type of test is one sample t-test. This test is designed to whether the mean of distribution differ, di- differs significantly from one present value. For example, performance of MPhil student and professor goal is 82%. So let the teacher want all students should get 82% mean GPA 4. So we will check the performance of the student, and then we'll find how many students are according to the desire of the teacher. So in this stage, we will apply one sample t-test. So in this test, we find the difference significantly in population and sample. Here is a small test. Can you tell me what type of test can we apply in these three examples? This is a question. I hope you will respond uh, me. No, what's the output of independent t-test? In output of independent t-test, we see we apply the Levine test of equality variance, and we will also see the difference. So summarize what the test of significance. The test of significance can be one tail or two tail test. Now, one may ask, what's the difference between one tail test and two tail test? So this definition has been given. Two-tailed two-tailed test examine whether the mean of one distribution differ significantly from the mean of other distribution, regardless of direction of positive and negative. So we do not see the direction in the two-tailed t-test. On the other hand, the one-tail test measures only whether second distribution differ in a particular direction from the first. So, in one-tail t-test, we see the direction, and in two-tail t-test, in comparing, we do not care the directions of distribution. Here is a simple uh, test for understanding the one tail or two tail. If you have stated your experiment hypothesis with care, it will tell which type of test you are looking for. Uh, Fill in is blank. For example, the hypothesis that coffee improve memory is what type of tail test? One type tail test or two tail test? You have to respond me. The hypothesis mean weigh a different amount from women suggests it is a one-tail test or two-tail test. So please insert the answer here. So remember, do not be vague with your hypothesis. If you are looking for a specific effect, be careful with the not hypothesis to avoid it. A does not affect B if you really mean A does not improve B. Result of independent sample t-test group. In the last example, we say if we compare the males and female of MPhil student of Alhamd University, and suppose that you have 64 female and their mean difference is 102.03, standard deviation is 13.896, and standard error is 1.737. The male number are 41. The means of male is 98.2. The standard deviation is 17.197. Standard error is 2.68C. So these are standard error of each mean separately, and we can find the standard error by dividing standard deviation by square root of the population. So, how close a sample mean might be the mean of population from which the sample came. It depends upon where we have taken the sample. Independent sample t-test, it has uh, equivalence variance assumed and equal variance not assumed. So, first of all, we apply Levine test for equality of variance. Levine test determined whether the variability from two groups is significantly different. If this were not significant, one might consider using the t-test for unequal variances. So we apply the Levine test for the equality of variance. Other important uh, parts of the independent sample t-test result is that the T, DF, significant column provide the statistical significant test. First, the T provide standardized statistic for the mean difference. So, T observed equal to mean 1 minus mean 2 divided by standard deviation. The t-test follow a non-normal distribution, non-distribution that depend on degree of freedom here. So degree of freedom is equal to 64 plus 41 minus 2. SPS calculate a t with 103 equal to 1.22 as two-tail probability of 0.22. So here you can see the p-value, and p-value actually tell us about the significant difference. So we have to summarize the independent sample t-test. So for we learn the following thing about the t-test. First, the t-test produce a single value t which grow larger as difference between the mean of two sample grow larger. Number two, t does not cover a fixed range such as a 0 to 1 like a probability do. Number three, you can convert p-value into probability called p-value. 4. The p-value is always between 0 and 1, and it tells you the probability of the difference in your data being due to sample error. Number 5. The p-value should be lower than a chosen significant 0.0, point 0, for example, before you can reject null hypothesis. So, if the value is less than 0.01, then you can find the test is significant. This value is called critical value. The point thing to do, compare this value with your value of t. If your t value is greater than or equal to this value, then t is significant and you have found a difference. If your t value is less than this value, then t is not significant. So you can find uh, whether the test is significant or not. It depends upon the p value. Independent sample t-test. T-test for equals of mean. So first we find mean difference, that is 3.739. Standard difference is 3.053. We have to take the lower bound and the upper bound between the 98 95% confidence interval of the difference. So this section provides a confidence interval around the mean difference. Calculation requires the appropriate critical value So critical equal MD plus the critical value into SED. So here you can find the difference between 3.739 and 3.739. The mean difference is the difference between two group means. There is nothing difference. The standard error of the difference is the function of two group individual standard error. T-test. When we apply the t-test in the experimental research, and in experimental research we take the two group. One is control group mean, other is treatment group means. So there is a first you can see medium variability in the picture, and in second you can say high variability and then the low variability. So these are three different types of variability. So you mean we can find the variability between these three. Next, the second type of test is the pair sample t-test. Pair sample t-test, uh, in in the test, we have the two quiz, quiz one and quiz two. So first of all, we see the means of quiz one and quiz two, then the number of participants, standard deviation, and standard error. So we can also find the pair sample correlation. Pairs correlation between pair 1 and pair 2. So number of participants are 105. Correlation is 0.673. So it's a strong correlation. Then the significance is 0.00, that is less than 0.05. So we can say this correlation signal, there is a strong correlation between the quiz 1 and quiz 2. Though the statistic is not shown, it provides a standard statistic for testing whether the correlation differ from 0. Page sample t-test. So you can see in this sample t-test, T observed is equal to minus 2.83, degree of freedom is 105, and significant is 0.00, that is less than 0.05. So this test is significant. The third type of test is one sample t-test. One sample t-test, first percentage number of participants 105, mean is 83.2, standard deviation is 12.135, standard error is 1.184. So one sample t-test has first t-value, then degree of freedom, significant tails of 2, mean difference, and then lower and upper bound. The mean difference is the difference between the sample mean and the user specific test value. After the t-test, we will also discuss one-way analysis of variance. In journal, we call it one-way ANOVA. So what's a one-way ANOVA? One-way ANOVA is like a t-test. Only difference is that we may we make the subgroup of our independent variable. For example, here ethylene group is a 1, and we can further divide this ethylene group into Asian, black, white, Hispanic, and take we check the examination score of the people. One way ANOVA will generate a significant value indicate whether there are significant difference within the comparison being made. This significance value does not indicate where the difference is or what the difference are, but a t-test can identify which group differ significantly from each other. So this is the result of one-way ANOVA. So in quiz 4, you can see the population. There is the Asian number of 20 is 20. Their mean is 8.35. Standard deviation is 1.53. Standard error is 3.343. Then we say lower bound and upper bound and minimum and maximum value. Similarly, we can see here all these values of black, white, Hispanic, and then we find the total. So such type in we apply the test of homogeneity of variance. So Levine statistic is 5.35, degree of freedom 1 is 3, degree of freedom is 2 is 96. So significant value is 0.003, that's less than 0.05. One way ANOVA, Christopher. Then we find between group sum of scale 34.24, degree of freedom is 3, mean score is 11.43, F is 2.24, and significant is 0.084. That is greater than 0.05. So we can apply this formula. You no need to memorize this formula. So similarly, we can find the within the group the sum of scale, degree of freedom, mean score, blah blah. So the result is sum of scale is the estimate of variance multiplied by the degree of freedom. It can be calculated in three ways. The sum of scale is that it can be deal with unequal subgroup size and they add like this. One way ANOVA. In one way ANOVA, other part is mean scale, F value, and significant difference. When F ratio is close to 1, the estimate value is said to be the similar. No indication of detectable difference between subgroup mean. When F value is greater than 1, estimate dissimilarly. Indication of difference between subgroup mean. SPSS calculate that an F with 3 and 96 degree of freedom that equal 2.272 has two-tier probability of 0.085. So after that, we apply the post hoc test. So these are the result of the post hoc test, and you can see here the significant difference of for all these values, and you can see in Asian and different group. Uh, Dear scholar, thank you very much. Your question are and comments are welcome.